What's up, guys? Welcome back to the channel. Today in this video, we'll be doing this question paper that you see here. This is a national certificate for mathematics N4, and this question paper was written on the 27th of March 2026. It was an X paper that took 3 hours to be written. Now, before we continue with this question paper, we'll do question 1, question 2, question 3, question 4, and question 5. So I'm going to leave the timestamp for each and every question that you would like to watch, just in case you don't want to watch this question paper in a sequence order. So before I start with question 1 though, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because we have made lots and lots of videos on previous question papers for N3, N4, and also N5. So without wasting any time, let's go to question 1. Let's do it. All right, here is our question 1. Let me just highlight it. This is our question 1, by the way. So question 1 consists of 3 questions. And it's based on graphs. So we're going to start with 1.1, and then we're going to do 1.2, and then we end with 1.3. So I'm going to create space, and then we do question 1.1 there. Let me create space, and let's do 1.1. All right, let's look at our question 1.1. Now, they want us here to draw a net graph of 9x squared plus 4y squared minus 36 is equaling to 0. Now, when you look at this, we need to simplify it first so that we can able to see what type of a graph is this one. So we have to transpose 36 on the right-hand side. So we have 9x squared plus 4y squared. If we transpose this negative 36 from the left-hand side to the right-hand side, we're going to have positive 36 there. Now, when I look at this, now I start to see that this is an ellipse. So if you don't know, there is a formula for ellipse. It goes like this. You have x squared divided by a squared plus y squared divided by b squared. All this is equaling to 1. So we have to make this equation to be equaling to 1. So when we have to do that, we have to divide by 36 throughout. So all the terms we divide by 36 throughout. Because when you divide by 36 divided by 36, that's going to give us 1. As for the first term, we're going to have x squared divided by 4. And the second term, we're going to have y squared divided by 9. And all this is going to be equaling to 1. Now, if you look at our general formula for ellipse, we can see that a on this one is equivalent to 4. In fact, a squared is equaling to 4. So we can say a squared is equaling to 4. And then let's look at b squared there. B squared is equivalent to 9. So we can say b squared is equaling to 9. Before we continue, you need to understand that a and b are actually the intercept of x and y. A is the intercept of x and b is the intercept of y. So we have a squared and b squared. We need to find a and b. So in order for us to find a and b, we need to square root both sides for a. Right, so our a here is going to be plus or minus 2 because the square root of 4 is actually 2. Same thing with b there. We have the square root b and 9 there. So b is going to be equaling to plus or minus 3 because the square root of 9 is actually 3. We know a and b. So let's draw the Cartesian plane and we can able to draw the graph. So here is our Cartesian plane. Let's start drawing the graph. So let's look at a. Remember, we said a is the intercept of x. So we know that a is actually plus or minus 2. So on x-axis, we're going to have a point there on the negative 2 and another point on the positive 2. Right. Now let's look at b. b is the intercept of y-axis. So as you can see, b is dividing y there. And in b, we have plus or minus 3. So we're going to have a point at positive 3 on y-axis and another point on negative 3 on the y-axis. Then from there, we connect the dots. So here is our ellipse there. So don't forget to name this graph here. You can name it x squared divided by 4 plus y squared divided by 9. All this is equaling to 1. or you can name it from the original equation there. So guys, this is how you draw the ellipse. I hope you know how to draw it, or I hope this part of the video helped you to understand how to draw this type of a graph. Just in case you did not understand, go to the point where you do not understand, rewatch at that point. And if that doesn't help, do not forget to comment on the comment section, and I'll try to answer you to my level best. But if this helped you to understand how to draw this ellipse, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 1.1, guys. Let's go and do 1.2. Here is our 1.2. Now, they want us here to draw a neat graph of y minus log base ex is equaling to 0. So first thing that we must do here is to simplify again, because it is not simplified. So by transposing this negative log base ex to the right hand side, we'll have the log graph. Y is going to be equaling to, if we transpose that log to the right hand side, we'll have log base ex like that. This here is the same as y is equaling to natural log x, just in case you do not know. In order for you to draw the graph of this log, I prefer that you use the table, guys. For me, the table is one of the easiest methods that you can use to draw the graph. So let's create a table and draw our graph. All right, so before we insert the x values here, there is something that you need to know, guys. The x values that you have to insert on this row here, they should not be less than 0 and also should not be 0. So we can say that x cannot be less than 0 or equaling to 0. So make sure that x is not less than 0 and it's also not equaling to 0. So we can put something like 0.5 there, maybe 1, 1.5, and also 2 there. So I have the multiplication of 0.5. If you put anything that is less than 0 on this row here, then you will have an error. This explains that our log graph doesn't intercept at y. It actually asymptote on the y-axis. So if we insert 0.5 here or there, the answer that I'm getting from my calculator is actually negative 0.7. There we go. And then when I insert 1 here or there, doesn't matter, one of the two, guys, they are all correct. You will get 0 there. If we insert 1.5 on this or that, the answer that we're going to get here, it's actually 0.4. There we go. And the last one, if we insert 2 here or there, we're going to get positive 0.7 there. So these are enough for us to actually draw our log graph. So let me create again the Cartesian plane and let's draw our graph. So here is our Cartesian plane. It's time for us to draw this graph here. Remember, guys, you don't really have to use the table for you to draw this graph, but it's best for me to use the table because it's one of the methods that is easier to explain and easy to draw this graph here. All right, so let's start with the first point. Now, here's our first point here. When x is 0.5, our y is negative 0.7. Now, 0.5 for x, it's here. So you take your ruler, you draw a straight line. So let me do it. And then again, you take a ruler, you draw a line from negative 0.7. Now, negative 0.7 on y-axis, it does not show there on our Cartesian plane. But you know that negative 0.7 is between negative 0.5 and negative 1. So in the middle there, we draw a line that is horizontal. Where they meet, that is going to be our point there. There we go. And then we have this point here. When x is 1, our y is 0. Our y is going to be 0 on the x-axis. So at this point here, this is going to be the point where x is 1 and y is 0. Right? And then we come to this point here. When x is 1.5, our y is 0.4. So 1.5 for x, it is here. We draw the line there. There we go. And then for y, we have to draw 0.4. So 0.4 is very close to 0.5 for y. So we say it can be here. We draw the line again. That is horizontal. Wherever they meet, this is going to be our point there. And then we go to the last point. So our last point says when x is 2, y is 0, 0.7. So x is 2 here. We draw the line there, vertically going upwards. And then we look at y. Y is supposed to be 0, 0.7. 0, 0.7 is between 1 and 0, 0.5. So we take a ruler again, we draw a fainted line that is horizontal. And then wherever they meet there, that is going to be our point. So let's connect the dot to draw this graph. There we go. So this here is our graph, guys. I hope you managed to see how we draw it. Now, what's so important about this type of a graph? It's this intercept here, the shape as well. It's very, very important. And for the fact that it's asymptoting on the y-axis. So if it so happen that you did not write these points here, you can always do this. Make sure that you show the intercept 1 and 0. This intercept here is very, very important. And another thing, do not forget to name the graph. So let's name it y is equaling to log base ex, or you can name it y is equaling to ln x, because these are one and the same graph. Guys, I hope you managed to understand how to draw this graph. They really love this graph, guys. So for you to draw this graph, it's best to use the table. But if you know the shape and where the graph is supposed to intercept, the table is really not that useful. But if you decide to use the table, do not forget that you cannot have your x entry that is below 0. So I hope this helped you to understand. If you did not understand how to draw this graph, you can go to the point where you did not understand, rewatch at that point, and if that doesn't help, leave a comment in the comment section. I will try to explain to my level best. But if this part helped you to understand how to draw this log graph, do not forget to like, guys, share, comment, and also subscribe to the channel if you haven't subscribed. All right, guys, we are done with this part of the question. Let's move on to the next part, which is this one here, right? So this part here, they are asking, what is the domain of the graph y minus log base ex is equaling to 0? So this is the question that they are asking. First of all, when they ask about the domain, they're basically asking on the x-axis. Where does this graph start and where does this graph end? On the x-axis, as you can see, the graph, it actually starts at 0 for x and it goes forever. If you look at the x-axis, it does not cut the y-axis and move on to this side. So we can see our graph starts at 0 and it ends at infinity, because if you look at this part here, it goes forever on the positive side of x. So that is the domain. So how are you going to write this? First of all, you can say x is greater or equaling to 0, because this graph here, it doesn't go to the negative side of x. So it's equaling to 0 or greater than 0. But at the same time, it's less than or equaling to infinity. If you look at this graph, it goes forever on the positive side of x. So it's going to be greater or equaling to infinity. So this is how you represent the domain of this graph. Again, I hope you understood this, guys. Really, this is not difficult. Just look at where the graph starts on the x-axis, because they say domain, and where it ends on the x-axis. So it starts at 0, but it does not have an ending. So hence we have infinity there. All right, people, I hope you managed to understand how to write the domain as well. Leave a comment if you did not understand. If you did understand, again, do not forget to like, share, subscribe. We are done with 1.2. Let's go and do the other question, which is 1.3. Let's look at 1.3. So the question goes like this. Draw the graph of y plus root of 25 minus x squared is equaling to 0. Now this graph here, guys, as well, it needs us to simplify it. Let's make y subject to the formula so that we can able to draw this graph. If we make y subject to the formula, you're going to have negative root 25 minus x squared. This here, guys, is actually a semicircle. Now you need to know certain things about semicircles. We have 4 types of semicircles in this level. We have the upper semicircle and the lower semicircle. We also have the left and right semicircle. Now, how do you distinguish between these four semicircles? Let's start with what this equation equaling to. This equation here is equaling to y. So any equation that is like this, that is equaling to y, just know it's a semicircle, but then you need to know that it's either is the upper semicircle or the lower semicircle. Now, to choose between the two, just know that these signs here, they will tell you which one is the upper, which one is the lower. Since we have a negative there, this means that this is a lower semicircle. Because of is equaling to y, is going to cut or intercept at y-axis. Because of this negative, it's going to be intersecting on the negative side of the y-axis. So in order for us to draw the semicircle, we need to know the radius. Remember, this equation is coming from this. This is a general equation for the semicircle. We have y plus or minus the root of r squared minus x squared. So in order for us to draw this graph, we need to know what is actually r. From what we are given there, we know that r squared is actually equaling to 25. So in order for us to find r, in this case, which is the radius, it's going to give us r is equaling to 5 because you have to root both sides. So our graph is going to cut at positive 5 and negative 5 for x-axis. As for y-axis, it's only going to cut on the negative side of y. So let's draw the Cartesian plane so that we can draw this semicircle. So we managed to find our radius. Now let's create the point. Remember, we said our graph is going to cut on y-axis and also on the negative side of y-axis. It means that now this point here is going to be a point for us, and this one here is also going to be a point, and that one is going to be a point. So we said this is a semicircle, but a lower semicircle. So let's connect the dots. There we go. So here is our semicircle. As you can see, it's intersecting at y-axis, but on the negative side of y-axis because of the negative there. So what you can do here, you can name this graph y is equaling to negative 25 minus x squared under the root. So basically, this is how you draw the semicircle graph, guys. I hope you managed to understand this one as well. Really, it is not that difficult. It can be confusing because we have lots of semicircles graphs there. But this one, it was the lower semicircle. Just in case this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you have some confusion, you can leave a comment in the comment section or watch at the point where you got lost. All right, guys, we are done with question 1 of this question paper. Here is our question 2 there. I hope you can see how I highlighted it. So it has 3 questions, 2.1, 2.2, and 2.3, with 2.2 having 2 sub-questions there. So we're going to start with 2.1, and then we're going to create some space so that you can able to solve it. So let's create some space and let's solve 2.1. All right, guys, here is our question, 2.1. Now let's read the statement and let's solve this question. Given here, we have x minus 3 divided by 3 plus y plus 4 divided by 5. All this is equaling to 7. So this is the first equation there. And the second equation, we have x plus 2 on the numerator, and they are all divided by 7, minus y minus 6 divided by 2. All this is equaling to negative 3. Determine the value of x and y using the method of Cramer's rule. So we are given these 2 equations, but they're in fractions. So we need to simplify these 2 equations. So what you can do here is to find the denominator for each and every equation. So let's start with the first equation there, which is x minus 3 divided by 3 plus y plus 4 divided by 5. All this is equaling to 7. We need to get rid of the fractions. So to make it linear, we need to find the LCD. So to find the LCD here, we have to multiply 3 and 5. This here is 15. There we go. Then we apply the following. We're going to divide this 15 with a 3. We know this is going to give us 5. Multiply the numerator there. So 5 is going to be multiplied by x minus 3 there. Plus, because we have plus there. So this time around, we're going to divide this 15 with that 5 there. And then the answer here is going to be 3. So that 3, we're going to multiply it with this y plus 4. So y plus 4, they're going to multiply the 3 there. All of this is equaling to 7. There we go. Now on the numerator, we need to get rid of the bracket. So this is going to give us 5x minus 15. On the second term, we have 3 multiplied by y multiplied by 4. So this is going to give us 3y plus 12. And then we can divide by 15 there. Right? So this is equaling to 7. So from here, we have like terms and we can also do cross multiplication. So let's start with the like terms. We have negative 15 and 12 there. So this, they're going to give you negative 3. Right? So we're going to write 5x plus 3y. Negative 15 plus 12, this is going to give us negative 3. All this is still divided by 15, equaling to 7. Right? So let's continue here at the top. Now we can cross multiply by multiplying this 15 with 7 there. We're going to have 5x plus 3y minus 3. This is going to give us 7 multiplied by 15. That is actually 105. There we go. And then we're going to transpose this negative 3 to the other side. So it's going to become positive 3. So we only left with 5x plus 3y. And then this negative 3 is going to become positive, right? And then the actual equation is going to be 5x plus 3y is equaling to 108. All right, guys, so this is our equation 1. Now we need to simplify equation 2 there. So we're going to continue underneath. Let me create some space a bit here. So the second equation is going to be x plus 2 divided by 7 minus y minus 6 divided by 2. All this is equaling to negative 3. Again, here we need to find our LCD. So our LCD here, it's 7 multiplied by 2. That is going to be 14. So we start 14 divided by 7. That is going to give us 2 multiplied by x plus 2. So this is going to be like that. And then minus, because we have minus there, guys, right? Then we have 14 divided by 2. That is going to give us 7. So that's 7 here. And then it's going to multiply y minus 6 there. There we go. All this is equaling to negative 3. Now let's remove the brackets. So on the numerator, we have 2 multiplied by x plus 2. That is going to give us 2x plus 4. There we go. And then minus, we have negative 7 multiplied by y minus 6. So this is going to give us negative 7y plus 42. Divide by 14. All this is equaling to negative 3. Right, so let's create space, guys, so that we can have our equations there. Now that we have created space, we have like terms here with 4 and we have 42 there. Now it's time for us to add these like terms. So we're going to start with 2x minus 7y, 4 plus 42. That is going to give us plus 46. All this is divided by 14, and this is also equaling to negative 3. So from here, we have to do cross multiplication. We multiply this 14 with negative 3, and then we'll have a linear equation. So let's continue. We have 2x minus 7y plus 46, and this is going to be equaling to negative 42. There we go. So from here, we have to transpose this negative 46 to the other side. So let's do it. We have 2x minus 7y, and then this is going to be negative 42 minus 46. Let's zoom down for now so that we can be able to finish this equation. So when we continue here, we're going to write 2x minus 7y. This is going to be equaling to negative 42 minus 46. This is going to give us negative 88. This is going to be equation 2. So let me just create space so that we can able to actually write this equation next to each other. So equation 1 is going to be 5x plus 3y is equaling to 108. There we go. So this is equation 1. So equation 2, it's 2x minus 7y, and this is going to be equaling to negative 88. This is equation 2. There we go. So from here, we can create the matrix in order for us to get the determinant. So when you create the matrix, guys, it's so simple. You only take the coefficient of x and y, and then you insert there on your matrix. So let's start with the first column. So the first column is for x, so we're going to take the coefficient of x. So it's going to be 5 and 2. There we go. And then let's move to the second column. The second column, we only take the coefficient of y, which is 3 and negative 7. As you can see, this now is our matrix. All this is equaling to determinant. So in order for us to calculate the determinant of this matrix, we have to multiply with the first entry and the last entry. And then the product of third entry and the second entry, they will subtract the first product. So let's do it. D is equaling to, this is going to be 5 multiplied by negative 7 minus. So in the next bracket, we're going to multiply 3 with 2, which is the second entry with the third entry. There we go. So if you use a calculator, this is what you're going to get. Negative 41. So this here is our determinant. We're going to use this determinant to find our x and y. So from here now, we need to find the determinant for x. So I'm going to write dx here, which is going to be equaling to. So we need also to create the matrix for dx. Now, since we are calculating the determinant of x, we know that x belongs on the first column. So what you're going to do here, we're going to substitute this entry with the constants there. The first entry we're going to take from the first equation, which is 108. And then the third entry we're going to take from the second equation, which is negative 88. There we go. And then we're going to keep these ones for y because we are not calculating for dy. So we have 3 and negative 7. There we go. So when you calculate dx, you're going to do similar thing that you did here. You multiply the first entry and the last entry there. So let's do it. So it's going to be 108 multiplied by negative 7 minus. Now you multiply the third entry with the second entry there. So we're going to have negative 88. Let me create space here with a 3 there. There we go. So your answer here for dx is going to be negative 492. There we go. So we are done with dx. Now it's time for us to calculate the determinant of y. So when you calculate the determinant of y, you also need to create the matrix there. If you create the matrix, now you have to take back these entries of x back there to the matrix. So we have 5 and 2. We're no longer calculating the determinant of x, so they must go back to the original. And then since we are calculating the determinant of y, we have to take the constant and include them on the second column because second column is for y. So here we're going to write 108 because the first row represents the first equation and the second column represents y. So we're going to put that there. And then the fourth entry is going to be negative 88. There we go. So from there, we calculate dy. dy is going to be equaling to, we multiply the first entry, which is 5, with the last entry, which is negative 88, right? Minus. And then we're going to multiply the second entry, which is 108, with the third entry, which is going to be 2. Now we put this on your calculator. dy is going to be negative 656. There we go. So these here are the determinants. They are not yet the actual values. So in order for us to calculate x and y, the following is required. X is going to be equaling to dx divided by d. So we know that we've already calculated d here. We also have dx there. So it's time for us to just substitute. We have negative 492 for dx divided by d, which is negative 41. So the final answer here is positive 12 there. So let's find y. When we calculate y, we're going to do similar there. We're going to have dy divided by d there. So dy, we know that is negative 656 divided by negative 41. So our answer here is going to give us 16 there. So as you can see here, our x is 12 while our y is actually 16. So you can check these answers whether they're correct or not by substituting them on this equation or that equation. So I'm going to choose the first one then. So we have 5x. Instead of writing x, we're going to write 12. And then we have plus 3 multiplied by y. Instead of writing y, we're going to write 16 there. So if you put this on a calculator, it should give us 108. So when I do that, I'm actually getting 108. So this proves that our x is correct as 12 and our y is correct as 16. Guys, we have done this type of problems on this channel. You can go to the playlist and search for determinant. I have a playlist that is all about determinant. I'm gonna leave again that playlist on the description, and also the icon at the top there is gonna pop up for the playlist that contains the determinant. All right, guys, we are done with 2.1, even though it was a bit long, but we are finished with it. If you have a question based on this 2.1, do not forget to comment on the comment section, and also try to watch at the point where you got confused. Maybe that will help you as well. But if this part of the video helps you to understand, do not forget to like, share, comment, and subscribe to the channel, because we have done questions like this, and also you'll be notified when we upload a video. All right, guys, we are done with 2.1. Let's go and do the next question, which is 2.2. All right, here's our 2.2, guys. Now we are given the matrix here. I hope you can see it. This is a 3 by 3 matrix. So let's look at the sub question of this 2.2. We have 2.2.1. They want us to evaluate the determinant. Expand only along the elements of row 1. So here on this question, they want you to use row 1 as the reference to get the determinant. So we're gonna highlight row 1 so that we can able to use it. So before we calculate the determinant, this means that row 1 entries or elements, they're gonna be minus. We need to write the signs here. So the signs goes like this. You have positive, negative, and positive. We have negative, positive, and negative. And you have positive, negative, and positive. So these signs, they're going to help us, guys, to find the determinant that they're asking us to get. So let's start. If you calculate the determinant, right, first you have to select from the row 1 as your minor. So when we have minor 3, meaning we're going to cancel the row at which 3 is and the column at which 3 is. There we go. So we cancel the row where 3 is and the column where 3 is. But we can see that this 3 correlates with the positive there. So here's how we're going to write this. We're going to write 3, and then we write the matrix that is remaining there. We are left with 7, 8, 9, and 6. There we go. Then we move to another one. So the next minor is going to be 2. So we can write minor 2, meaning we need to cancel the row and the column where 2 is. Right. So let's look at 2 there. 2 correlates with negative them. So we're going to write the negative 2 first, and then we'll write the matrix that is remaining there. We're left with 4, 9, 1, and 6. There we go. Now let's move to the last minor, which is minor 5. There we go. Now from here, we have to cancel the row and the column where 5 is. There we go. Now when you look at 5, correlates with positive there. So this here is going to be plus 5. And then we write the matrix that is remaining there. We're left with 4, 7, 1, and 8. There we go. All right. So the next step from here, we're going to continue like this. We have this 3. So it's going to be multiplied by the following. We multiply the first entry, which is 7, multiplied by 6 minus. And then we have the second entry multiplied by third entry, which is 9, multiplied by 8. And then we close the bracket there. minus 2. And then we open the bracket again. We have 4 multiplied by 6 is the first bracket, minus by the second bracket, which is 9 multiplied by 1. That is 9 multiplied by 1 there. And then we have the last one for minus 5. So inside the bracket there, we have 4 multiplied by 8. 4 multiplied by 8 minus 7 multiplied by 1. So from here, you use a calculator. Right, so if you put this on our calculator, the first term here is going to give us negative 90 minus, right, 30, like that. And then the last term here is going to give us 125. So when you add these together, the answer here, I'm getting positive 5. So our determinant is actually 5. Like I said earlier on question 2.1, we have done determinant. So there is a playlist on the description and on the icon at the top right of this video. Go and click on that playlist. You will see that I've done something similar to this on this channel. Or you can go to the playlist and search for determinant and watch each and every video there in order for you to understand better. But if this part of the video helps you to understand better, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you do not understand, you can also leave a comment or rewatch at the point where you do not understand. All right, people, we are done with 2.2.1. Let's look at another sub-question, which is 2.2.2. All right, guys. Now, here's our 2.2. It goes like this. Evaluate the cofactor of element 8. Now, here, they want us to find the cofactor. There is a formula for cofactor. When you calculate the cofactor, guys, it goes like this. Cofactor is equaling to, we have inside the bracket, negative 1 to the power of I plus j multiplied by minor. Right. So I'm going to try to explain what is the meaning of these things here. Let's start with I and j. I and j are basically row and column. If you have a minor, for example, minor, it's going to be written like this, I and j. There we go. I is actually row, and then j is actually column. So since our element is 8, which is this here, but at which row is our 8? So as you can see, this is the third row there. So we're going to write 3 there instead of writing I. And then what column is our 8 there? It's on the second column. So we're going to write 2 instead of writing J there. There we go. So it means that J and I, they're actually 3 and 2 respectively. So if you continue here, we're going to have negative 1, right? And then we have I plus J. So we have 3 plus 2 multiplied by the minor. So how are we going to write this minor? It's very simple, guys. The minor is the matrix that we're going to have when we cancel the row at which 8 is. Let's do it. And the column where 8 is. Remember, 8 is the one that we're going to use as our reference. So what is it that we left with here? We have 3, 4, 5, and 9, like that, right? So when we continue, we're going to have negative 1 to the power of 2 plus 3. That is going to give us 5 multiplied by, let's continue here. We're going to multiply the first entry and the last entry there, which is 3 multiplied by 9. There we go. Minus by the second entry and the third entry, which is 4 multiplied by 5. Then we close the bracket there. So negative 1 to the power of 5, that is going to give us negative 1 multiplied by, inside here, we have 3 multiplied by 9 minus 4 multiplied by 5. That is going to give us 7 there. So if we continue here, we have negative 1 multiplied by 7. This here is going to give us negative 7. So the cofactor of the element 8 is actually negative 7. Guys, I hope you managed to understand this. As you can see here, we use a different formula. There is another formula that you can use to calculate the cofactor. So if you want to learn about that formula, you can go to the playlist and search determinant and then there is a video where I calculate the cofactor using a different method. If this helped you to understand how to calculate the cofactor, do not forget to like, share, comment, and subscribe to the channel. If you haven't subscribed to the channel, subscribe to the channel because I've made loads and lots of videos on this subject. If it so happens that you do not understand, don't forget to leave a comment and I'll try to help you to my level best. And you can also watch at the point where you got lost. We are done with 2.2. Let's go and do the last question, which is 2.3. All right, guys, here is our 2.3. Now, on this question, they want us to simplify the following expression that you see here, and they want us to leave it to rectangular form. They also want us to show all the steps there. So what you're going to do here, as you can see here, we have a fraction and we also have the power there for both numerator and denominator. Now, if I look at the numerator, we have 10 cis 126 degrees. This here is actually polar form. So we can rewrite it like this: 10 polar 126 degrees divided by. And also on the denominator, we have 2 multiplied by cos 72 plus I sine 72. Guys, this is also another notation for polar form. So we can write it in this notation. We have 2 and then we have polar 72. Or you can use the cis notation. It's all good, guys. But let's not forget, all of this has the power of 3 there. It means we need to use De Morgan's theorem. But before you use De Morgan's theorem, we have 2 complex numbers that are dividing each other in a polar form. So when you have 2 complex numbers that are dividing each other in a polar form, the modulus, they will divide each other. So if you continue, this is going to be 10 divided by 2, and then polar, we have 126 degrees. The one on the numerator, when it comes to the argument or the angle, it's going to be positive, and the one on the denominator is going to become negative there, which is 72. But let's not forget, all this has the power of 3. So let's continue. We have 10 divided by 2. This here is going to give us 5. And then we have 126 minus 72. This one here is going to give us 54 degrees. Let's not forget, all of these, they have the power of 3. Now we can start using the De Morgan's theorem. Now with the De Morgan's theorem, I'm going to do it here on top. The modulus, which is 5 there, is going to have 5 to the power of 3 there. And then as for the argument, which is 54, is going to be multiplied by 3 there. So if you continue, 5 to the power of 3, we know that this is going to be 125 there. And then we're going to have polar 162 degrees there. Right. Now, remember, they want us to leave this in a rectangular form. If you don't know rectangular form, guys, we have a real number and imaginary number. So in order for us to convert this to rectangular form, we need to use the formula that was used here. So let's go back. Now we're going to have 125, right, multiplied by cos 162 plus imaginary sine 162, right? So what you're going to do here, we're going to multiply throughout with 125. 125 multiplied by cos 162, I'm getting negative 118,88. And then I will multiply this 125 with I sine 162. So what I'm getting here is positive I 38,627. There we go. So this here is a rectangular form. We have a real number here and we have an imaginary number there. So guys, this is how you solve this question. I hope you guys managed to understand how to solve this type of a question. As you can see here, we use the De Morgan's theorem, and also we divided complex numbers in a polar form. And lastly, we converted from polar form to rectangular form. Again, I'm going to leave a playlist that contains all the methods that we use to solve this problem here on the description, just in case you want to learn about them. and the very same playlist is going to pop up on top of the video that you're watching at the current moment. So guys, we are done with 2.3. If this question helped you to understand how to solve this type of problems, do not forget to like, share, subscribe to the channel if you haven't subscribed. And also you can comment on the comment section. If you did not understand, go to the playlist and watch the videos. And if that doesn't help, you can always watch at the point where you get confused. Thank you very much for watching. We are done with question 2. Next is going to be question 3 of this question paper. All right, guys, here is our question 3. Now, question 3 consists of 4 questions from 3.1 to 3.4. So it's based on trigonometry. We're going to start with 3.1 and then we're going to continue and do other questions. So let's create space for 3.1 and then we solve it. All right, guys, here is our 3.1. Let's read the question and let's solve this problem. So they want us here to solve for theta if 3 sine squared theta minus 4 sine theta minus 5 is equaling to 0. Now we are given the restriction here, or the domain. Our theta should be greater than or equaling to 0, but should be less than 360 or equaling to 360. You know, from 0 to 360, it's actually one cycle. So we're going to consider all the 4 quadrants of the cast diagram. Let's rewrite this question. We have 3 sine squared theta minus 4 sine theta minus 5. This is equaling to 0, right? If you can look at this expression here, this is actually trinomial. If this confuses you, you can substitute sine with x. For example, you can write this equation like this: 3x squared minus 4x minus 5. All this is equaling to 0. I'm not going to do the substitution method. I'm just going to continue the way we were given. Now, with the way things are, it's best for us to use the quadratic formula. So let's use the quadratic formula. We have sine theta. It's going to be equaling to negative b plus or minus root b squared minus 4ac divided by 2a. Let's name our variables here. We know that 3 is a, negative 4 is b, and negative 5 is c. Let's continue and substitute our variables then. So sine theta is equaling to negative b, but instead of writing negative b, we're going to write negative 4 there, plus or minus inside the root there. So this is going to be negative 4 squared minus 4 multiplied by a. A, remember, is 3 there, multiplied by c. C, it's negative 5. All this is divided by 2 multiplied by a. Remember, a is 3 as well. So we continue here. We know that sine theta is going to be equaling to, we multiply negative with negative 4. This is going to give us positive 4, plus or minus. So inside the root, if you put this inside the calculator, we are getting 76 divided by 2 multiplied by 3, that is 6. Right. So let's create space so that we can continue solving this problem. Right. So if you continue, remember we have plus or minus there. We have sine theta is equaling to 4. Now, this time around, we're going to put plus there, root 76 divided by 6. Or we have sine theta. This time, we're going to have 4 minus root 76 divided by 6. Right. So if you put this on a calculator, sine theta is going to be 2,12. There we go. And then the other one is sine theta. If you put that on a calculator, you're going to have negative 0,786. There we go. So we have these 2 values for sine theta. So both of these, we have to use them to get our theta. Let us not forget all of them. Let me create space so that we can able to solve this question. Let's look at these here. This is a very important part. Now we have this one here where sine theta is equaling to positive 2,12. Now it means that whatever the angle we're going to get here should be at the quadrant where sine is positive. So let me draw the cast diagram on the side so that we can able to use this information. All right, so here is our cast diagram in green. Since sine is positive, we don't need to find the reference angle. And we know that sine is positive on the first quadrant and the second quadrant. So let's find our theta. If we say theta is equaling to, we're going to transpose sine to the other side. It's going to become arc sine 2, 1, 2. What do we get? This here, the answer is going to be invalid. Meaning, for this one, theta is error or invalid. Now it's time for us to focus on the second one then, where sine theta is equaling to negative 0.786. Now, on this one here, we know that sine is negative on the third quadrant and the fourth quadrant. Now, since this sign is equaling to a negative number there, or it's negative, it means we need to first find the reference angle. So how are you going to find the reference angle? It's not that difficult, guys. What we have to do here, we can say theta is equaling to, and then we transpose our sine to the other side. This is going to be arc sine 0.786. Remember, when you calculate the reference angle, you get rid of the negative there. As you can see, we do not have the negative there. This is not an answer, it's just a reference angle, right? So when you do that, my reference angle is going to be theta is equaling to 51.813 degrees. There we go. It's time for us to use the information on our cast diagram. Remember, we said sine it's negative, but where on the cast diagram? On the third quadrant and the fourth quadrant. So theta is actually equaling to 180 plus, remember on the third quadrant is 180 plus the reference. So our reference is 51.813 degrees. This here is going to give us 231.813 degrees. So this one here is one of our answers. So we're going to continue here underneath for the angle on the fourth quadrant. So theta is going to be equaling to 360 minus reference angle, which is 51.813. There we go. So our angle here is going to be 308.187 degrees. So this one as well is going to be our final answer. I hope you guys managed to understand this. If you did manage to understand, do not forget to like, share, comment, and subscribe to the channel. If you do not understand, you can always leave a comment in the comment section. I'll try to explain to you to my level best or rewatch at the point where you got lost. Again, if you don't know much about cast diagram, you can always go to the description. I will leave the link with the playlist that has all the trigonometric basics that you need. Click on that playlist and the very same playlist will pop up at the top right of the video that you're watching at the current moment. All right, guys, we are done with 3.1. Let's go and do 3.2. All right, guys, here's our 3.2. Now let's read the question and solve this one here. This is simplify the following expression. We have on the numerator cosec plus cot divided by tan x plus sin x. So here they want us to simplify this. So I would say let's rewrite this so that we can able to solve it nicely. So let's open the bracket then. Remember cosec is the same as 1 over sin x. There we go. Plus. And then we know that cot is the same as cos x divided by sin x. Then close bracket. Instead of writing this line here, we can write this as the division sign there. We can also change our tan there and make it sin x divided by cos x. There we go. Plus sin x divided by 1. Close bracket like this. What I just did with tan and cot is what we call the quotient identities. So that's why you can change cot into cos over sine. You can also change tan into sine over cos. Right. So on the first bracket, we have the same denominator, which is sine x there. So we can write 1 plus cos x on the numerator then. Right. Let's not forget we're still dividing here. Now, on the second bracket, we have to find the LCD. The LCD here is actually cos x. And then cos x divided by cos x we'll have 1 multiplied by sine x. There we go. Then plus, because we have plus there. And then we say cos divided by 1. The answer is going to be cos multiplied by this sine there. So this is going to be cos x multiplied by sine x. Right, so we close the bracket like this. We're going to continue. So we can rewrite this 1 plus cos x divided by sine x as it is. There's nothing we can do at the moment, but we can change this division into multiplication. So we know that when you change division into multiplication, the numerator become the denominator and the denominator become the numerator on this bracket then. So our denominator here is cos, so it's going to become cos x on the numerator. The numerator, it was sine x plus cos x multiplied by sine x. Now it's a denominator. All right, guys, let's create space so that we can solve this problem here. Right, so when you look at this problem here, the first one, we're going to write it as it is. We have 1 plus cos x divided by sine x multiply. On the numerator, we're going to leave cos x as it is, but on the denominator, we have the common factor there. Our common factor is sine x. And then when you take out the common factor, we have 1 plus cos x. There we go. This 1 plus cos x and another 1 plus cos x, they're going to divide each other. So basically what you're left with here, you'll be left with 1 sine x multiplied by cot x divided by sine x. Right. So 1 over sine x is the same as cosec x multiplied by cos x divided by sine x. That is also cot x. So this here is our final answer, guys. I hope you managed to understand this one here, guys. Just in case you did not understand, you can go to the point where you got lost, rewatch at that point, and if that doesn't help, you can leave a comment at the comment section. But if this type of video help you to understand this type of a problem, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Again, guys, there is a video on inverses on that playlist. So go to that playlist, watch the videos on inverses just in case you didn't understand. All right, people, we are done with 3.2. Let's go and do 3.3. All right, guys, here is our question, 3.3. Now, they want us here to derive a formula for 1 over sec 2 theta in terms of sine only. Now, we need to use the reciprocals here or the inverses to solve this. We know that 1 over sec is actually cos. So we can write this as cos 2 theta. There we go. They actually want us to find the double angle identity of cos, which contains sine only. So this, we know that is equaling to cos squared theta minus sine squared theta. This is another identity for cos 2 theta. Remember, they want us to derive this in terms of sine only. We can use this square identity, sine squared theta plus cos squared theta is equaling to 1. And we can make cos squared theta subject of the formula. If we do that, we have to transpose this sine squared theta to the other side. So we'll have cos squared theta is equaling to 1 minus sine squared theta. There we go. So what we're going to do here, we're going to substitute this cos squared theta to that one there. So let's continue. So we can write this as 1 minus sine squared theta minus this one here, sine squared theta. So the answer here is going to be 1. We have 2 negative sine squared thetas here. So this is going to give us 2 sine squared theta. This here, guys, is the answer that they were looking for. I hope, again, you managed to understand this. The trick here was the inverse there. So like I said earlier on question 3.2, that I've already left the link of the playlist that contains all the basics when it comes to trigonometry. So go and click on that link, watch those videos, and then you're able to understand how I get to the point of cos 2 theta. Just in case this helps you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you did not understand, Do not forget to go to the point where you got lost or comment on the comment section, and I'll try to help you to my level best. All right, guys, we are done with 3.3. Let's go into the last question, which is 3.4. All right, guys, here's our 3.4. Now, 3.4, they want us to prove that the left hand side is equaling to the right hand side. Now, when you prove, guys, always choose the side that is most complicated. As you can see here, the left hand side is the one that is more complicated. So I'm going to choose the left hand side, and then I'm going to prove that is the same as the right hand side. So let's do it. Let's look at the numerator there. We have cos squared x minus cos x minus sine squared x. So this sine squared x, we can change it in terms of cos. How we're going to do that? Remember, from this square identity, we can able to make sine subject formula. If we transfer this cos to the other side, we will be left with sine squared x is equaling to 1 minus cos squared x. There we go. So let's do it. So we're going to start with cos squared x minus cos x minus. Then instead of writing sine squared x, we're going to write 1 minus cos squared x. 1 minus cos squared x. There we go. Divide by. On the numerator there, I can see that we have the common factor. We have 2 sine x cos plus sine x. So sine x is our common factor. If we take out our common factor, which is sine x, we're going to be left with 2 cos x plus 1. If we continue, on the numerator, we're going to have cos squared x minus cos x. Then we multiply by negative to remove the bracket. So this is going to be negative 1 plus cos squared x. Divide by sine 2 cos x plus 1. There we go. So here on the numerator, we have the like terms. We have cos squared x with another cos squared x. They're going to add and give you 2 cos squared x. But you're left with negative cos x minus 1. All this is divided by sine x, open bracket, 2 cos x plus 1, close bracket. Right, so let's create a space here so that we can solve this question. Let's look at our numerator then. Our numerator, guys, is actually the trinomial. We need to factorize it. So we can say open bracket, 2 cos x, close bracket, and then we have cos x as well, and close bracket. We know that 2 cos x multiplied by cos x, that is going to give us 2 cos squared x. Then we need to find the factors of 1 there. So the factors of 1 is 1 and 1. But then we have negative there. So we need to multiply this 2 cos x with negative 1. And then we have positive 1 there. Then we divide like that. So we still have sine x 2 cos x plus 1. There we go. And then 2 cos x plus 1 and another 2 cos x plus 1. They're going to divide each other. So we only left with cos x minus 1 on the numerator. Divide by sine x. There we go. We are not finished, people. We need to prove that this is equal to the right hand side. Let me create space for the last time, and then we prove. So we can continue and write like this: cos x divided by sine x minus 1 over sine x. Remember, you can able to do this because this line here is solid. So we can able to break it like that. So we know that cos x over sine, that is going to give us cot x, minus, we know that 1 over sine, that is actually cosec x. There we go. If you can look at the question, you can see that this is equaling to the right hand side. There we go. I hope you guys managed to understand this. Again, most of the methods that I applied there, you can learn them from the playlist that I left on the description because it has the basics of trigonometry. But if you manage to understand this, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Right. If you did not understand, you can always watch at the point where you get lost or leave a comment in the comment section and I'll try to help you to my level best. Guys, we are done with question 3. Alright guys, here's our question 4. Now question 4 consists of 5 questions. from 4.1 to 4.5 is based on calculus, limits, and differentiation. So we're going to start with question 4.1. We'll create a space for this one and then we solve it. All right, guys, here's our 4.1. Let's look at the question and let's solve it. Now, 4.1, they want us to expand this expression here. We have x plus 2y, all this to the power of 7. So they want us to actually expand to 4 terms. So we have to do binomial theorem for this. So before you do binomial theorem, I think the best thing you should do here is to write the equation and then you substitute from there. So we know that the equation of the binomial theorem, we have x plus h to the power of nth, and then we expand it to 4 terms. So the first term is x to the power of nth plus the second term is n multiplied by x to the power of n minus 1 multiplied by h. And then the third term is n multiplied by n minus 1 divided by 2 factorial multiplied by x to the power of nth minus 2 multiplied by h to the power of 2. And then the fourth term, which is the last term, it's n multiplied by n minus 1 multiplied by n minus 2. All this is divided by 3 factorial and multiplied by x to the power of n minus 3 multiplied by h to the power of 3. Right, so this is the formula for binomial theorem. So you need to know what is n, what is x, what is h in this case. So you can write underneath here. Let me use a different color. From this equation here, we can write that x is actually x, h is actually 2y, and then n is actually 7 then. And then from there, we start substituting. So let's do this. So if we write this equation there, we know that we have x plus 2y to the power of 7. So we start substituting. The first term, we have x to the power of nth. X is x here, so it's going to be x. Nth, it's 7, so we're going to write 7 then. That's the first term then, right? And then the second term, we have this following there. We have n multiplied by x to the power of n minus 1 multiplied by h. So we can say plus our n, remember it's 7 there. And then we have x to the power of n minus 1. N is 7 minus 1, that is going to give us 6. So that is going to be the power of 6. Multiplied by h. Remember, h here is actually 2y. So you're going to write multiplied by 2y. There we go. We are done with the second term. Now it's time for us to do the third term, right? So let's continue. Plus. So the third term, we have n. Remember, n is 7 multiplied by n minus 1. 7 minus 1, that is going to give us 6 divided by 2 factorial. So this is 2 factorial. And then we have x, which is x there, to the power of n minus 2. Remember, n is 7. So 7 minus 2, that is going to give us 5. There we go. Multiplied by h to the power of 2. So we still remember h is actually 2y. So it's going to be 2y to the power of 2. There we go. That is the third term. Then we do the fourth term. Again, we just substitute there, guys. We have n, which is 7 multiplied by n minus 1, which is 7 minus 1, that is going to give us 6, multiplied by n minus 2, which is 7 minus 2, that is going to give us 5, divided by 3 factorial. There we go. And then multiply by x to the power of nth minus 3. So it's going to be 7 minus 3, and that is going to give us 4. So we have the power of 4. Multiply by h cubed. Remember, h is the same as 2y there. So we're going to write 2y cubed. There we go. Then from here, we're going to start using our calculators. So let's continue. The first term, we know that this is going to be x to the power of 7. And then the second term, we have 7 multiplied by 2 there. That is going to give us 14. So we have plus 14. And then we have x to the power of 6 multiplied by y. There we go. And then we have the third term. Now, the third term, in your calculator, insert the following. You're going to insert these ones on your calculator, multiply by 2 to the power of 2 there. Don't include y on your calculator. If you do that, you must be able to get plus 84x to the power of 5y squared. Now we move to the fourth term. Again, we're going to take all of this, insert it in our calculator. And let's not forget we have 2 to the power of 3 as well. When you do that, we're going to get plus 280 x to the power of 4 y cubed. So this here is how you actually calculate this problem here. We have the first term, the second term, the third term, and the fourth term. So we managed to expand this to fourth term. Guys, I hope you managed to understand this. If it so happened that you did not understand, I'll leave a video that explains how to apply binomial theorem on the description, and the very same video will pop up at the top right of the one that you're watching at the current moment. And you can always leave a comment if that doesn't help as well. If this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Alright guys, we are done with 4.1. Let's go and do 4.2. Right guys, here is our 4.2. Now 4.2, they want us to determine the limit here. So let's start with the first method. Remember, the first method is direct substitution. So let me rewrite this. We have limit x approaches 1 over 2, right? And then we have 2x squared plus x minus 1 divided by 2x squared minus x. Now the first method is to do direct substitution. So we know that this is going to be 2, but x is approaching half. So wherever there is x, we substitute with half. So it's going to be half squared there plus half minus 1. All this is going to be divided by 2x squared, which is half squared minus half. There we go. So if I use my calculator, on the numerator there, I'll get 0. On the denominator, I'm also going to get 0. So 0 over 0 is actually infinity. So when this happens, when you do direct substitution and your answer is infinity, we move to the second method, which is simplification. Now, if you can look at this expression here, we can actually simplify. So let's simplify. We have limit x approaches half, right? On the numerator, we can factorize them. We have 2x, and then we also have x there. X multiplied by 2x is going to give us 2x squared. And then the factors of 1 is going to be 1 and 1. Since we have positive in the middle there, this one here is going to be positive, because if you multiply with 2x, it's going to give us positive 2x. And this one here is going to be negative. Negative 1 multiplied by x, that's going to give us x. When they subtract, they're going to give you x, the one in the middle there. Then we divide. And then on the denominator, what we have there is a common factor. Our common factor is x, so we're going to be left with 2x minus 1. There we go. Now, if you look at the numerator, we have 2x minus 1 here, and we have another 2x minus 1. They will divide each other. So basically, what you're left with here is actually x plus 1 divided by x. There we go. So from there, now that we managed to simplify, we can start doing direct substitution. So let's do it. Wherever there is x, we're going to substitute with half. On the numerator, we're left with x plus 1. So instead of writing x plus 1, we're going to write half plus 1. Remember, wherever there is x, we substitute with half. Divide by x. So the x there, we're going to divide by half. Now, if you put this on your calculator, the answer here is going to be 3. So our limit here, guys, is actually 3. I hope this helped you to understand how to calculate limits, guys. Just in case you did not understand about calculating limits, I'll leave a playlist that contains problems that we solve when we are calculating limits. Go to the description. You'll see the playlist there. And also the very same playlist will pop up at the top right of the video that you're watching at the current moment. Alright guys, but if this helped you to understand, don't forget to like, share, comment, and subscribe to the channel. We are done with 4.2. Let's go into 4.3. Alright guys, here's our 4.3. Let's read the statement and solve this problem. Now in this question, they want us to differentiate y is equaling to cubic root of x squared minus 1 using a function of a function, chain rule. So basically here, they want us to differentiate this expression here using chain rule. So it's not a problem, guys. If you know a chain rule, this is not much of a challenge. So before we use the chain rule here, we need to simplify this expression that is given to us here. Rather change the sides into exponent. So you can write y is equaling to, open bracket, we have x squared minus 1, close bracket, to the power of 1 over 3. 1 over 3 is the same as cube root, just in case you didn't know. So when it's like this, it's easy for us to use the chain rule. We can say let u equaling to x squared minus 1. The function inside here, we're going to equate it to u. Since u is equaling to x squared minus 1, we can say y is equaling to, remember x squared minus 1 is u, you can write u there, to the power of 1 over 3. There we go. Simple, straightforward. So the next step here, we have to derive both these two functions and then we multiply them and then we'll get our answer. So let's look at the first function there. When you derive this, it's going to be du over dx. Remember, we are deriving u with respect to x. It's a standard derivative, guys. This is going to be 2x. There we go. Simple, straightforward. And then we derive this one here. Now we derive y with respect to u. So we know that dy over du. Now this is also the standard derivative. So it's going to be 1 over 3 multiplied by u, 1 over 3 minus 1. Then if you continue, this is going to be 1 over 3 u to the power of negative 2 over 3. There we go. Then from there, the formula for the chain rule is as follows. Dy over dx is equaling to, you multiply du over dx with dy over du. Right. When you multiply this, they're going to give you dy over dx. So let's continue. Du over dx is actually 2x there. So you're going to write 2x there. Multiply by dy over du, which is 1 over 3 u to the power of negative 2 over 3. So we're going to write multiply by 1 over 3 u to the power of negative 2 over 3. There we go. We are not finished because we still have u there and we have the exponent, which is negative. So we can start by multiplying by 2x there. Multiply by 1 over 3 u to the power of 2 over 3. Remember, this 2 over 3 is negative there. In order for it to be positive, the base must go to the denominator so that the sign can change like that. Again, we are not finished here. We need to change u back to x squared minus 1. So on the numerator, we left with 2x divided by 3. Now u, remember, it's x squared minus 1 to the power of 2 over 3. Right. So you can leave it like this. 2x divided by 3. And then we can change all of this into suds. Remember, we can write cubic root and then we have x squared minus 1 squared there. This is what it means there. The fraction as an exponent is the same as cubic root x squared minus 1 square under the cubic root. So this is our final answer here, guys. I hope you managed to understand this one as well. It was not much of a challenge, but just in case you did not understand, I will leave the playlist that contains questions that we are solving using chain rule. Go to that playlist on the description, click on it, and the very same playlist will pop up at the top right of the video that you're watching at the current moment. Right, guys, we are done with 4.3. If you managed to understand, do not forget to like, share, comment, and subscribe to the channel. Let's go and look at 4.4. Let's look at 4.4. Now 4.4, they want us to differentiate the following. Y is equaling to cos x divided by 3 ln x using a quotient rule. So this is one of the rules that they want us to use. The quotient rule, guys, we have a formula for it. I am gonna write it on the side here. It goes like this. When you are given y is equaling to f of x divided by g of x, when you differentiate this, it's very simple. You first differentiate your f of x, and then you multiply by g of x minus. Now you leave f of x, and then you differentiate g of x. You divide, and then you square g of x on the denominator. Basically, this is the formula for quotient rule. Now, if you can look at that equation there, our f of x here, which is the numerator in this case, is actually cos x. Then our g of x is actually 3 ln x. There we go. So I would say let's differentiate our f of x. What's the derivative of f of x here? We know that cos x, the derivative of it is going to be negative sine x. This is a trigonometric function. And then let's differentiate g of x. G of x prime is going to be, what's the derivative of 3 ln x? That is going to be 3 divided by x. Then from there, all we have to do is we substitute these on that equation there. So let's do it. Dy over dx is equal to the first term on the numerator. It says the derivative of f of x. So it's going to be negative sine x multiplied by g of x. G of x, it was 3 ln x. There we go. Minus the second term is you multiply f of x with the derivative of g of x. So f of x, we know that is cos x, and the derivative of g of x, we find 3 over x. There we go. All of this is supposed to be divided by g of x squared. So what is our g of x? Is 3 ln x. Then we square this. Guys, you can leave it like this. Don't go further than this. Our answer is complete like this. In your level, there's no simplification required. Just in case you did not understand, again, I'm going to leave a playlist that contains problems like this, where we differentiate using quotient rule. Click on that playlist, and the very same playlist will pop up at the top right of this video. It will help you to understand how to solve more questions like this one. All right, people, if this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with 4.4. Let's go into the last question, which is 4.5. All right, guys, let's look at 4.5. Now, 4.5, they want us to differentiate with respect to x. We have a polynomial here, guys. So before we do any differentiation, we need to first identify each and every term. What type of a function is it? And also, we need to identify each and every term that needs to be simplified. Now, if I look at these terms here, we have this one here. We need to simplify it. We cannot differentiate with the trigonometric ratio on the denominator. We have this term here where we have a root. We cannot differentiate with the root there or sad. We have this term here where we have e to the power of negative x. We cannot differentiate with a variable on the denominator that has x there. So we need to simplify these. So I'm going to rewrite the whole of this polynomial so that we can able to differentiate. So we're going to have y is equal to, let's look at the first term. We have 2 sec x. There's no simplification required. We're going to write 2 sec x. There we go. Minus the second term, we have 4 cosec 2x. So it's going to be minus 4 cosec 2x. No simplification required. The third term, we have plus 6 ln x. No simplification is required as well. And then we have the fourth term, we have 5 to the power of 4x. No simplification is required. But the fifth term, we have 1 over 2 cot x. So we can change 1 over cot into tan. So we can write first 1 over 2, and then we can write multiply by tan x. There we go. And then we move to this one here, the that last term. We have negative 3 cubic root of x. So we can write negative 3 x to the power of 1 over 3. This is the same as cubic root, guys. 1 over 3 as exponent. Plus, we have p there. So p is fine. We're going to leave it as it is. And then minus, we also have 1 over 4 e to the power of negative x. We can take e to the numerator, so we can have 1 over 4 multiplied by e to the power of x. Remember, if you take the base to the numerator, the exponent changes the signs there. Plus, the last term, we have x to the power of 3. Now, when it's like this, we can able to differentiate each and every term. So let's do it. Right, so let's start. Dy over dx. Let's start with the first term. We have 2 sec x. Now, 2, we know is our coefficient. We need to derive sec x. Now, the derivative of sec x, guys, it's sec x multiplied by tan x. There we go. Now, let's move to the second term. The second term, we have negative 4 cosec 2x. Now, negative 4 is actually the coefficient. Now, we need to derive cosec 2x. Now, when we derive a trigonometric ratio that has the coefficient of x, we have to multiply by that coefficient first, which is 2 in this case. And then now we derive cosec. So the derivative of cosec, guys, if you still remember, is negative cosec 2x multiplied by cot 2x. There we go. Then we move to the third term. Third term, we have plus 6 ln x. So we know that 6 is a coefficient. The derivative of ln x, we know that is 1 over x. So 6 multiplied by 1 over x, going to be 6 over x. There we go. Now we move to this term here, which is the fourth term. We have 5 to the power of 4x. Now this one is exponential. So with exponential, we have to multiply by the coefficient of x there, which is 4 there, multiplied by the base, our base, which is 5 to the power of 4x. Then we introduce ln base 5 plus the coefficient here, we have half, so 1 over 2, that's the coefficient. And then we have to derive tan them. The derivative of tan is sec squared x. There we go. And then we move to this term here, negative 3 x to the power of 1 over 3. Now the coefficient is negative 3, and then we have to multiply by 1 over 3. Remember, this is the standard differentiation. Multiply by x to the power of 1 over 3 minus 1. There we go. And when we move to the seventh term, p is a constant, so this is going to be 0. Right, let me just zoom down so that we can create space in order for us to finish this. Now let's do the second last term there. So the coefficient there is negative 1 over 4, right? And then we differentiate e to the power of x. So we have e to the power of x, that's the derivative there. Then the last term there, we have x cubed. So this is going to be a standard derivative, it's going to be 3x squared. There we go. So we are not completely done. We need to simplify each and every term. So let's do it. We have dy over dx, right? The first term, it is simplified. We're just going to write it as 2 sec x multiplied by tan x. There we go. And then the second term, we have negative 4 multiplied by 2 multiplied by cosec 2x cot 2x. So this is going to be plus 8 cosec 2x multiplied by tan 2x. There we go. Nothing is changed there. It's 6 over x. There we go. And then we move to the fourth term. We have 4 multiplied by 5 to the power of 4x ln 5. So nothing changes on this one. So we move to the fifth term. We have half multiplied by sec squared. So this is going to be half multiplied by sec squared x. There we go. Now we move to the sixth term. On the sixth term, we have 3 divided by negative 3. We're going to be left with negative 1. Then we have x to the power of 1 over 3 minus 1. So this is going to give us negative 2 over 3 as the exponent plus 0. So even if we don't add the 0, we move to the second last term. We're going to write negative 1 over 4 e to the power of x plus the last term, which is 3x squared. There we go. This here, guys, is our final answer. But you can always write it like this. Dy over dx. We have 2 sec x multiplied by tan x plus 8 cosec 2x multiplied by tan 2x plus 6 over x plus 4 multiplied by 5 to the power of 4x ln 5 plus half sec squared x. Now on this term here, which is the third last term, we have negative x to the power of negative 2 over 3. So we can change this into positive exponent. So we can write it as 1 over x to the power of 2 over 3 minus 1 over 4 e to the power of x plus 3x squared. Guys, you can leave it like this. This is correct. So this is our final answer. All right, people, I hope this helped you to understand how to derive this polynomial. Just in case you did not understand this, I will leave again a playlist that contains different type of polynomials that we differentiated. You can click on that link, and the very same link will pop up at the top right of the video that you're watching. So click on it to watch other polynomials similar to this one that we solved. But if this part of the video helps you to understand, do not forget to like, share, comment, and subscribe to this channel if you haven't subscribed. We are done with question 4. I hope you managed to understand the entirety of this question 4. We'll be doing question 5. All right, guys, here is our question 5. Question 5 consists of 5.1, 5.2, 5.3, and 5.4, with 5.3 having 2 sub-questions there. So we're going to start with question 5.1, solve it, and then we're going to do others later on. Let me create space so that we can able to solve this 5.1. All right, guys, here is our question 5.1. The one asked here to evaluate the following integral. Now, as you can see here, we have the limits there. Once you see the limits on the sigma, just know this is a definite integral. We need to simplify this expression before we integrate. So let's do it. As you can see, the upper limit there is pi over 2. So when you have pi over 2, it just know that that is in radians. You can change that into degrees by multiplying pi over 2 with 180 over pi. And then if you multiply this is going to give us 90 degrees. Just in case you didn't know. Rather use degrees than radians. So if I rewrite this is going to be sigma. The upper limit is 90 degrees. The lower limit is 0. And then if you look at the numerator there, we have sine 2x. Sine 2x is a double angle identity that we can write as 2 sine x multiplied by cos x. There we go. And then we divide by cos x there. Close bracket, then dx. Then from there, we know that cos and cos, they divide each other. You'll be left with sigma, upper limit 90, lower limit 0. And then you are left with 2 sine x multiplied by dx. Now, when it's like this, we can start integrating. Now, when you integrate the definite integrals, there's no need for you to add c there. So let's integrate this one. We have y is equaling to, open bracket, we have the coefficient, which is 2 there, and then we integrate sine. So the integral of sine is actually negative cos x, then close bracket. Now, let's not forget that we have the upper limit, which is 90, and the lower limit, which is 0. Let me continue on top here. So as you continue, this is going to be as follows. The first bracket is going to be for the upper limit. If we multiply these two with negative cos x, this is going to be negative 2 cos x. There we go. Then we close the bracket. This is for the upper limit. Then we subtract them. Now, the second bracket is for the lower limit. It's going to be the same integral there, which is negative 2 cos x. Then that is for the lower limit. Then from there, what we do here, we start substituting. Now from here, we substitute the limit wherever there is x. So on the first bracket, we're going to substitute 90 wherever there is x. So we have 2 cos 90 degrees, close bracket, minus. And then on the second bracket, we have negative 2 cos 0. Remember, on the second bracket is for the lower limit, which is 0. So when you continue here, for the first bracket, we have negative 2 cos 90. That is going to give us 0. And then minus. And then inside there, we have negative 2 cos 0. That is going to give us negative 2. So the final answer, our limit is going to be positive 2. You can write unit squared there. There we go. This is our final answer for this question. Guys, this is what we call definite integrals. Just in case you did not understand how I did this one, I'll leave a playlist that contains the problems that we solve on definite integrals. Go to the link on the description, click on it, and also the very same link will pop up at the top right of this video. But if you manage to understand this, you can always leave a like, comment, subscribe, and also share the video if you know someone who's doing N4. All right, people, we are done with 5.1. Let's go and do 5.2. All right, guys, here is our 5.2. Now 5.2, they want us to simplify this integral here. So this integral, as you can see, it has three terms there. So before we integrate here, we need to simplify first, then we integrate later. Now let's start. We have sigma there, and then we have 3 sine x over cos. We know that 3 is a coefficient. Sine x over cos x, that is going to give us tan x. There we go. Plus. Now the second term, we don't do anything. It's fine like that. And then the third term, we have 7 there. We also don't do anything. Now, when it's like this, we can able to integrate. Now we integrate. We know that 3 is a coefficient. But then what is the integral of tan x? When I look at the formula sheet, the integral of tan x is actually ln sec x. There we go. And then we move to the second term with pi over x. This is the integral of natural log. So the answer here is going to be plus pi ln x. There we go. And then we go to the last one, which is 7. 7 is our constant. Remember, when you integrate the constant, you multiply by the variable that you're integrating with respect to. In this case, that is x. So this is going to be plus 7x plus c. So here, this is our final answer, guys. Really, you're not supposed to worry about this one because it was straightforward. So, guys, this is how you do it. Just in case you didn't understand, you can always watch at the point where you got confused. And if that doesn't help, you can leave a comment in the comment section. I've done videos on integrating polynomials. I'm also going to leave a playlist that contains those integral of polynomials. All right, people, we are done with 5.2. Let's look at 5.3. All right, guys, here's our 5.3.1. Now, they want us to sketch the graph of y is equaling to 4x squared and y is equaling to 2x. Calculate the point of intersection, show the area to be calculated, and the strip to be used. So we have two graphs here. One is y is equaling to 4x squared. Let's call this one y1. And y2 is equaling to 2x. There we go. So we have these two graphs here. We need to draw them. Now let's start with y1. For the fact that we have x squared there, this is actually parabola. It's just that we do not have b and c. We only have a, which is the coefficient of x squared. So this graph here, what matters the most is the sign of the coefficient of x squared, which is a. And then let's look at graph 2 or y2. This is a straight line graph because we have x and then c is actually 0. We don't really have to find the coordinates here because since c is 0 for both of them, it means these graphs here, they will cut at 0, 0 point. Right, so let me draw the Cartesian plane and let's draw this graph. So this is all we need for these two graphs. Let's start with graph 1. I'm going to draw it using a red color. Like I said, this graph 1 or y1 is actually a parabola. For the fact that our 4 is positive, we know that when a is positive, our graph will face upwards. Now that we don't have c and b, meaning our graph is going to turn and cut at the origin there. So let me draw the graph and show you how exactly it's supposed to look like. There we go. So this is actually our graph. Guys, when you have a graph like this, especially a parabola, you don't really have to worry too much about it. Just know that you can draw it this way. You can also use the table if this doesn't make sense. Right, so let's look at y2, which is a straight line graph. Again, the straight line graph, we do not have c. It means our graph is going to cut there at 0, 0. For the fact that our graph is equaling to 2x, it means that our graph is going to pass at 0. So here's our graph going to look like. There we go. So here is our straight line graph. So these two graphs here, they interact them. So remember, they say we must show the area that we need to calculate. So the area they want us to show is the area that is created by these two graphs. So let me highlight that area. So this is our area. Let me first name these very quickly. This is y1, which is equaling to 4x squared. And this here is y2, which is 2x. Now, remember, they say we must show the representative strip. So the representative strip is supposed to be inside this area there. So let me just put it here. You can put it anywhere as long as it's inside the area. Change in X. There we go. So this is exactly how they want us to draw or sketch our graph there. But let's not forget, they also want us to calculate the point of intersection. Now, the point of intersection that they're talking about are these points here, that one and the origin. So as for the origin, it's 0, 0. Even if you don't calculate here, this is 0, 0. The one that we need to find is the one here on top. So as you can see, both of these graphs, they're equaling to y. So in order for us to find those point of intersection, we need to equate these two graphs. So if we equate them, we can say 4x squared is equaling to 2x. There we go. And then we solve for x. We're going to transpose this 2x to the other side. So we'll be having 4x squared minus 2x. All this is equaling to 0. Then from here, we can take out the common factor, which is 2x. And then we're left with actually 2x minus 1. This is equaling to 0. Now, when it's like this, we know that 2x is equaling to 0. And this one, if you transpose this negative 1 to the other side, we have 2x, which is equaling to 1. And then x here is going to be equaling to 0 if you divide by 2. And here, x is going to be 1 over 2. There we go. Now we need to find the y values. So in order for us to find the y values, we can substitute these x values in one of these two equations. So rather substitute them in y2. So y is equaling to 2 when x is 0. So y is going to be equaling to 0. So we can say point A, we have 0 and 0, which is this one here. Already I've written it. Now let's look at the other one. We can substitute half there. 2 multiplied by half, and then this here is going to be equaling to 1. So we can say point B, when x is half, our y is 1. So this is the point here, half and 1. There we go. So these are the intercept that they were talking about. I hope you managed to understand these ones. Really, it was not that difficult. This is actually grade 12 work. But just in case you did not understand, you can go to the point where you got confused, rewatch at that point, and if that doesn't help, you can leave a comment on the comment section, and I'll try to help you to my level best. But if this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with 5.3.1. Let's go and do 5.3.2. All right, guys, let's look at 5.3.2. The question goes like this. With the aid of integration, determine the area bounded by the two graphs. So they want us to calculate the area that we highlighted in yellow there, which is created by these two graphs. So in order for you to calculate this area, you need to know the upper limit and the lower limit. So the formula is like this. A is equaling to sigma. The upper limit, let's say, is x2. The lower limit, let's say, it's x1. Then inside here, we have y2 minus y1. I'll explain this later on, multiplied by dx. Now, let's start. Remember, we have area, which is equaling to sigma. Now, x2 is the upper limit. How are you going to find the upper limit here? Guys, the upper limit is the x coordinate of these two intersections, which is bigger. So in this case now, half is the one that is bigger than 0 here. So we're going to write half there. And then the lower limit, it's actually this one here, which is 0. So this is going to be 0. You only take the x coordinate of the intersections, guys, not the y coordinate, because you are actually integrating with respect to x. So that's why the x values. Remember, the upper is the one that is bigger. The lower is the one that is smaller. Right. Now let's explain why are we saying y2 minus y1. Right. If we look at the area that we highlighted them, it's going to help us which one is going to be negative and which one is positive. As you can see, we said y2 is positive. Y2 is positive because the green graph, which is y2, when you look at the area that we highlighted in yellow, the green graph is at the top of that area. So that's why that is positive. So remember, y2 is actually 2x. There we go. And then the red graph, which is y1, the parabola, it's underneath the area that we highlighted them. So this is going to be minus 4x squared, which is y2. So we multiply by dx, by the way. Then from there, we just apply our definite integrals. So let's do it. We know that a is going to be equaling to, then we integrate this. These are standard integral, guys, so you don't have to worry about them. So we know that this is going to be 2x 1 plus 1 divided by 1 plus 1. There we go, minus. And this is going to be 4x 2 plus 1 divided by 2 plus 1. Then we close them. We write the upper limit, which is half, and the lower limit, which is 0. Guys, when you do definite integral, there's no need for you to add plus c there. Right, so let's continue. If you continue, area is going to be equaling to, we're going to have the first bracket, which is going to be 2x squared divided by 2, minus, we have 4x cubed divided by 3. Then we close there. So the first bracket is for the upper limit, which is half, minus. Then the very same integral that we got here on the first bracket, we're going to write it again. So it's going to be 2x squared divided by 2 minus 4x cubed divided by 3. And then we close the bracket. Let me create a space here so that we can finish our problem there. Let us not forget our lower limit, which is 0. Right, so we continue. As we continue here, you can see that 2 and 2, they're going to divide each other. You're only left with x squared. But instead of writing x squared, we're going to write 1 over 2 squared, because we start substituting x with our limit there. In this case, it's half the upper limit. And then we say minus, and then we have 4. And instead of writing x cubed, you're going to write 1 over 2 cubed divided by 3. And then we close the bracket there, and then minus. And then on the second bracket, we're going to substitute with our lower limit, which is 0, wherever there is x. So it's going to be 0 squared divided by 2, minus 0 cubed divided by 3. And then we are done there. Then we move on. On the first bracket then, we got 1 over 12 minus. And then the second bracket, it's 0. So the final answer is actually 1 over 12 or 0,083 unit square. Guys, this is our final answer when we calculate our area. I hope you guys managed to understand how to calculate the area. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you got confused somewhere, you can always watch the point where you got confused. And again, I have left some playlist on the description on how to do definite integrals, which is what we applied on this question. All right, people, we are done with this question here. All right, guys, here is our 5.4. They want us to integrate the following here. So we have to simplify the terms that need to be simplified here. As I look at this, I know that the last term needs to be simplified because we cannot integrate with the root on our term there. So let's do it. So we have sigma, and then the first term is still fine. We have 3 cos, and then we have half multiplied by x minus a to the power of negative x, plus we need to change that cubic root x into x to the power of 1 over 3 dx, like that. But we are not done because we cannot again integrate with x on the denominator. So we need to take this x to the numerator. So we're going to rewrite the first two terms again. We have 3 cos half x minus a to the power of negative x. If we take this x to the numerator, our 1 over 3 as an exponent is going to be negative 1 over 3, close bracket, dx. So when it's like this, we can start integrating. Now let's integrate. So y is going to be equaling to the first term. We have 3 cos half x. So we have the coefficient, which is 3. The integral of cos half x, we know that is going to be positive sine half x. But then we know that our x has a coefficient of half. We need to divide by half them. There we go. Minus. The second term is exponential integral. So when you integrate exponent, you first write a to the power of negative x divided by Now, the coefficient of x, you must multiply by it on the denominator with ln base a, right? And then we move to the third term. The third term, remember when we integrate this, it's very, very simple. It's going to be x to the power of negative 1 over 3. Because this is a standard, we add plus 1. And then we divide by negative 1 over 3 plus 1 plus c there. There we go. Then from there, we start simplifying. Let me create space so that we can simplify this one further. So let's continue. If we continue here, the first term, we can multiply these two with a 3 there. This is going to give us 6 sine half x. There we go. Divide by this one. Even if you don't write 1, it's still fine. And then we see we have negative and negative there on the next term. So that is going to give us positive. And then we have a to the power of negative x divided by ln a. There we go. So we can say plus, let's start with x there. We have x to the power of negative 1 over 3 plus 1. That is going to give us positive 2 over 3 as an exponent. Divide by the same 2 over 3. There we go. Plus c. So we are not completely done because we still have a fraction on the denominator. So if you write the final answer, this is going to be y is equaling to 6 sine half x plus a to the power of negative x divided by ln a plus, now we have to multiply by 3 on the numerator there. So this 3 is going to be there. And then we have x to the power of 2 over 3 divided by 2 plus c. So this here is our final answer, guys. I hope you managed to understand how to integrate this polynomial. Like I said earlier, if you don't know how to do polynomials, I left the playlist on the description. Go and click on the polynomial integrals and you will see different type of polynomials that we integrated. Just in case you manage to understand this, do not forget to like, share, comment, and subscribe to the channel. We are done with question 5 and we are also done with the whole question paper. So guys, I hope this video helped you to understand how to solve this type of questions. Until next time, guys, thank you very much for watching. Cheers.